Okay, so we're going to find out how this has anything to do with similar and congruent triangles. I'm not sure if it does, but it says a rectangle has four sides perpendicular to each other. The slope criterion says that if this line has a slope that's not 0, then another line has a slope that is -1 over the other slope, so the inverse, the negative inverse of the first slope, then the two lines are perpendicular at the point where they meet. What that basically means is if you calculate the slopes, the two slopes, then multiply them together, they should come out to equal -1. That's what that says. And this whole thing about the slope not being 0, well, when we have a 0 slope, that is a horizontal line. So we would say that when the slope is 0, the only time that something is going to be perpendicular is if it's a vertical line, and vertical lines have a slope that's undefined. So that's just a separate one you have to know. Horizontal lines have a slope of 0, vertical lines have a slope of undefined, and if you have a 0 slope, then you must have an undefined slope in order to prove that they are perpendicular, and vice versa. You have a vertical line, then you have an undefined slope, you must have a 0 slope or a horizontal line for them to be perpendicular. So anyway, here it says, is the quadrilateral with vertices P is -6,2, Q is -3,6, R is 9, -3, and S 6, -7. Is that a rectangle? We're supposed to answer yes or no. And the way we're supposed to prove this is by finding the slopes of the four sides. So let's find the first side. It's PQ. I'm going to do this one by hand. P is at -6,2, and Q is at -3,6. And I'm just going to remind you, I'm going to do it by hand because, if that's how you want to do it. But I'm going to show you a way that I consider a bit faster. So here we go. Let's do these by hand. So you might remember the formula, which is the slope formula says y minus y over x minus x, right? And maybe you remember the dump truck, if you ever remember that old story here. It helps you remember how we take the ordered pairs and we tip them so that we get the y over the x. We tip them that way always, so y ends up over the x. All right, so in this case we end up with, let's put 6 over -3, if I dump this one, right? And then subtract, right, 2 over -6. And what would that slope be? Well, 6 minus 2 is 4. -3 minus a negative, that's going to be +6. Right, so -3 plus 6 is going to be +3. So the slope of PQ is 4/3. So you would do that for QR, RS, and then back to SP, and you would, try multiplying them out. So that's by doing them by hand. I'm going to try and see if I can do them even quicker using Geogebra. So we have, if I pull up Geogebra down here in my input, I say P equals ordered pair -6, 2, and Q equals ordered pair -3, 6, and I hit enter. And then I just drag my thing down here where I can see P and Q. And if I make a segment connecting them, I can measure their slope using my measurement tool for slope. Touch the slope there. We have 1.33 repeat. That would be repeat, which is 4/3. Okay? So now, I'm just going to put the rest of the coordinates in from this problem, which is R is at 9, -3, so capital R equals 9, -3. Oops, -3, and I got to make that not plus, but equals. Okay. And S is going to be where? 6, -7, so capital S equals ordered pair 6, -7. Enter. All right, so now I've got to find where R and S ended, so I'm going to move my screen. There they are. And I'll just make my polygon. I'll make it's not a regular polygon, I'll just use the polygon tool here. P to Q to R to S and back here. So now I can just use my slope tool and find out each of the slopes as I go, right? And I can see that indeed this is it appears to be a parallelogram so that the opposite sides are parallel to each other. But that doesn't prove that it's a rectangle. Now, the easiest way to prove that something is a rectangle, especially once you have it drawn, is to measure the angles. So we'll do that real quick. We'll just measure our angles. And if I have this angle, let's say RSP, if that's a right angle, then they probably all are, but we could double check. If both of these are, then the others are for sure, because we know opposite sides are parallel, or opposite angles are congruent in a quadrilateral, in a parallelogram. So if these are right angles, those are too. But how else would we get there? Well, you know, negative 0.75 is negative 3 over 4. So if I were to go back here, I said, you know, one of my slopes was positive 4 over 3. My other slope was negative 3 over 4, right? Because that was negative 0.75. If I put that in a fraction, and now if I multiply those guys together, the 3's are going to cancel, the 4's are going to cancel, leaving just negative 1 over 1, which is negative 1. So that's the slope criteria. So we can put these into our Khan Academy as our answer. This one would be negative, this one was 4 over 3, right? And QR was, which one was QR? Let's check Geogebra. That one was negative 3 over 4, negative 3 over 4. And then the next one is RS, and RS is 4 over 3 again, 4 over 3. And that means the last one was negative 3 over 4 again. So this is a rectangle, and we check our answer. Now, I'm not quite sure how that has anything to do with triangles, that one. But let's see. Cuts a rectangle into two congruent right triangles. So we're going to have a quadrilateral with vertices, right? There's the vertices. Is it a rectangle? We find the measure of the lengths. Oh, that would be the distance formula. That's ugly. And then find the lengths of the diagonals. And then we could determine, I guess, by side, 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 if those two right triangles are congruent. This does not look, to me, like a similar triangle problem. But we have negative 6, 2, negative 3, 6, 9, negative 3, and 6, negative 7. So now what we need to do is find the lengths of the four sides. So PQ. Well, this is why we love Geogebra. It's just such a great tool. So that length is measured right over here at 5. I can see it as 5. So I just put 5 in for PQ. And QR, that's the second one, that was 15. So I'll put 15 over there. And then RS is going to be 5. And SP will be 15 again. Okay, and now we've got to construct the diagonals. So let's get a segment between them from P to R, and that's 15.81 approximate. Boy, we better figure that out by hand, and then because that's approximate. And there's our other one. And I think they're going to want an exact answer. So let's that's a good one. We can do kind of we'll use Pythagorean Theorem here to do that one real quick. Here we go. So Pythagorean Theorem, just to remind you, it says that the measure of one leg squared plus the measure of the other leg squared is equal to the measure of the hypotenuse squared, right? So we should be able to confirm that here. Let's go to our, paper here, and we'll write it out. So again, that's leg squared plus leg squared equals the hypotenuse squared. In this case, our legs are 15 squared plus 5 squared is equal to the hypotenuse squared. Well, I happen to know that's 225 plus 25 equals our hypotenuse squared, right? So that's 250 equals the hypotenuse squared. If I take the square root of both these sides, I get the hypotenuse is equal to the square root of 250. Well, that sounds okay, but there's a perfect square inside of here because this is equal to 25 times 10. So we're going to try and figure that out a little bit. The square root of 25 times the square root of 10, which is equal to, square root of 25 is 5. So 5 root 10 is our hypotenuse. Let's see how they want us to put that in there. So square root 10 we're going to put. So we're going to go 5 square root 10. There we go. That's our correct answer. And this one would also be 5 square root 10. There we go. Was there any more we had to answer here? Oops, is it a rectangle? And the answer is yes. It's the same one we just did. All right. One of the most recognized paintings. Ah, yes, now we have something very good here. The Mona Lisa, okay, has one of the most recognized paintings in the world, the golden ratio, which is roughly equivalent to 1.62, phenomenon of beauty found in art, music, nature, and throughout the Mona Lisa. If the Mona Lisa is 77 centimeters tall, that's from top to bottom, so that's the length of this side here, and 53 centimeters long, okay, and that is given to us, right? And then triangle AZ, where's Z? AZC, this triangle here is isosceles. So I'm guessing what that means is side AZ must be the same as side CA. Those two have to be the same. For AZC to be an isosceles triangle, we need two lengths to be the same. AZC. So I know that C, that's the measure of just a single mark. And this one right here has a single mark. So this ZC is the same measure as AY, but AZ is longer. So for AC to be equivalent, it's going to have to be equivalent to AZ. There we go. AZ to AY is equal to CX to CY, which is equal to 1.62 to 1. So this length here is 1.62 to 1. All right. What is the approximate distance from the midpoint of the top edge at T to Mona Lisa's eye at point Y? So we're trying to find this length right here. Ooh, but we're given that this is the midpoint. Okay. And we know that, let's see. We know that this length is equivalent to these two lengths together. All right, this is going to be a good one. We're going to take a pause while I work some stuff out, and then I will take you through the answer. Okay, so I was kind of running out of time, and that's why I paused it so I could work out these calculations. There's only a couple minutes left in this recording here. So basically, we knew this side, 1.6, well, this side was equivalent to that side. And the ratio of this side to that side is that this is equal to 1 and this is equal to 1.62. So this is equal to 1.62. We consider this to be equal to 1.62 and this to be equal to 1. So what I did was I said, okay, let's take a look at these triangles here. Let me take a look at these triangles that we formed. And on this side, I said, okay, this whole side is the equivalent of 1.62, and this one is the equivalent of 1. So I knew that this was the midpoint, and we could divide our triangle, and I knew that these isosceles triangles were going to be similar, because I knew the sides, all three sides are equal. These were marked equal, that's a reflexive property, and this was the midpoint. So by side, 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 these are congruent triangles right here. The whole thing we were told was 53 centimeters, which means half of it was 26.5 centimeters, which represent on the scale 0.81. So then I write an equivalent ratio that says if 0.81 is to 26.5, 1 is to what? And then I just let the calculator help me figure that out. I said, what is x? And that told me that the length of this hypotenuse here had to be 32.716. Okay, and then the last thing I did was I used Pythagorean Theorem. Pythagorean Theorem told me that this leg squared, which was 26.5 squared, plus this leg squared, which was the unknown, so I called it L squared, would be equal to the hypotenuse squared, which we knew was 32.716 squared. And I said solve it for L, and it gave me 19.1856, and I'm going to plug that in right now, about 20.